The actual big focus of this talk and this presentation is giving you guys a little peek and example on how to start working with AR Foundation. And so if you've been following our blog post or some of the work we've been doing, you know that that's something that was just released last Friday. So I'm excited to kind of share it with you guys and show you how easy it is to get started there. So I mentioned handheld AR, and again, the focus of this talk is on basically the SDKs of ARCore and ARKit. So those are developed by Apple and Google. And by that, we're talking about just augmented reality that kind of exists on these mobile devices, such as phones or tablets. And so how does it work? So the way that handheld AR works is that it uses something called visual inertial odometry. And what that is it's a resolution from the camera feed using computer vision, as well as the IMU sensors on the device. So things like the accelerometer and the gyroscope are able to kind of understand the device's position and rotation, and then using computer vision, kind of detecting these feature points, you can start to build out and the device understands the world. Now, one of the really unique and cool things about handheld AR is that once you've kind of established a plane or start to understand the world a little bit, your device becomes a sixed-off device. And this means that you can move it kind of throughout the world, and it understands its own position and rotation. As you spawn objects in the world, you can easily do kind of distance checks against the camera and things like that. And you could also easily kind of track out or create like a motion path as you move through the environment. All right, so now let's talk a little bit about getting started with ARCore. So ARCore is Google's AR solution. We actually had a couple workshops here at Unite Berlin, just kind of walking through the implementation at a high level. If you're looking to get started, you'll probably want to go to Google's GitHub repository here, which I've listed. And the nice thing is that they have some really basic sample scenes. So those sample scenes are things like Hello AR, which is pre-configured to find both horizontal and vertical planes, and then place little kind of prefabs of Andy the Android on top of it. And it also uses one of the unique features to ARCore, which is oriented feature points. You can see that there's a couple other sample scenes included there as well. If you're looking to kind of recognize images, things like posters or some sort of static image, ARCore now supports augmented images, and there's a sample scene kind of included in there as well. And the nice thing is that a lot of these scenes are fairly basic. If you wanted to replace Andy the Android with, say, a 3D model of your own, you could easily kind of change out the prefab that's included in that Hello AR scene. So one thing to note for using this implementation of ARCore, which is basically the Google SDK, is that we've now kind of directly integrated it in the engine, and there's a little checkbox in the XR settings. And you can see it's compatible with 2017.1. So a couple unique features that they have is Google's actually built what they call the instant preview. And so you can see here, this is actually a small GIF of me back in the office configuring and modifying a material in the Unity editor that's actually running off of my Android device. And so this allows you to basically hit the play button in the editor, it pushes an APK to your Android device, and then actually streams the AR data back into Unity. So this is super helpful when you're trying to iterate quickly, kind of do some debugging and things like that. Some of the other unique feature points, or some of the other unique features, and one that I mentioned earlier was oriented feature points, and this is basically finding a feature point in the world and then getting a directional vector back from it. So if you wanted to place an object on, say, a slanted surface or kind of attach it to different areas where maybe you couldn't find a full plane, you can use this feature for that. And last but not least, they also released Cloud Anchors, which is basically a solution for creating multiplayer experiences within the ARCore environment, where you can basically place an anchor, sync it up to the cloud, and then resolve that on another device. So you're kind of seeing the same AR experiences between devices. So as I mentioned earlier, it comes with this little Andy prefab, which you see here, and basically From a high level, you can see that it has this kind of hello AR controller. This is just a component in the scene. And you can see that Andy, the Android prefab, is just kind of selected there. It has a couple nice UI elements as well. So that snack bar is basically what they've just named a kind of UI window that informs the user to start looking for planes and then kind of goes away when you've selected it. And the other thing to note here is that the way that ARCore is kind of handling its sessions, and this is kind of an idea that you'll see a little bit with our AR Foundation as well, is that these are just scriptable assets. And so if you are trying to take advantage of certain features on ARCore, you need to make sure that you're using the right session data and that you've configured your session through there. So you can see things like the augmented image database, so that actually is a scriptable asset as well, and you kind of assign that specifically in your session, and then you can also configure what types of planes you want and things like that. So for the augmented images, I actually am really fond of this kind of implementation. It's super straightforward. You can kind of multi-select any images within your project and just right-click them, which Google's kind of created a sub-menu inside the Create menu that you can see there. And then it actually goes through, packages up all of those images into a single scriptable asset. And you'll notice as well is that it actually scores the images as it's kind of processing them. So that's that quality kind of column there. And what it does is it gives you various scores based on how easy the computer vision can kind of recognize and track those objects. Now they suggest creating images with a score of 85 or higher. And then there's also that width tab, and that actually helps the computer vision algorithms and the recognition. If you know the kind of size of the image that you're looking for, this can help kind of narrow it down and recognize it a bit quicker. One thing to note is that these databases can actually contain up to 1,000 images. So if you had something like a magazine or had a lot of different ones, you can kind of go and add those all to a single database and then ship that with your application. There also is some support for streaming in images. They do need to go through this kind of compilation step in order to get associated with it, but that is a feature as well. All right, so that was ARCore, just kind of a high-level overview, how you can start getting started. If you wanted to, swap out Andy and start spawning things, you can go ahead and do that. And now I'm just going to go over some of the ARKit. So unlike ARCore, which is developed, the SDK is developed through our partnership with Google, our ARKit plugin is actually developed in-house by us. So this is mostly, or a lot of the heavy lifting has been done by an engineer back in San Francisco called Jimmy, and he actually puts all of the assets up on this Bitbucket link. And the nice thing here is that because he's working so closely with Apple, he's able to put out new features and put out the branches right as they're announced. Now, obviously, Google does that as well as they release features. But, for example, ARKit announced a bunch of new features at WWDC recently, and Jimmy already had those ready. As the features were announced the same day, the beta branch was pushed up to our plugin, so you could start taking advantage of those right away. So that's really exciting. The other thing that Jimmy's done and some of the engineers at Unity is that we've built up a lot more sample scenes. So with ARCore, you get basically the base functionality. It's super easy to kind of swap out prefabs. With ARKit, there's a ton of sample scenes specific to some of the features, some of the UI and UX that you should consider when developing with AR. And the way ARKit is kind of structured is that it also encompasses face tracking, which is available on the iPhone X. So if you wanted to get started with that, this is all kind of included with this ARKit plugin. And you can see there's also some really nice features like shadows and occlusion. So those are basically special shaders that we've included in the plugin. And you can apply those to planes that you find if you wanted to kind of hide objects behind real-life objects. If you were able to find a plane here and it was using the occlusion shader, you could kind of walk around and things like this. And then the shadow one, which I use in a lot of my projects, is basically a transparent shader that accepts shadows to be able to be cast on it. And again, you can kind of place that at the base of your objects and get realistic shadows for the exact shape of the object. And as I mentioned before, all the 1.5 features are just mainlined on kind of the master branch, and then the 2.0 beta features are on their own separate branch that you can get access to. Again, so right now, the way that Apple has structured it for kind of the newer features and things like that, it's going to be on any Apple device running on 11.3 plus, and we've updated the plugin to be in the 2017 lifecycle as well. So some of the unique features with ARKit, and a lot of these are kind of available in ARKit 2, so that's the beta that just came out. Both Google and Apple are working on a lot of different features. Some of them, as you'll see with the foundation, have some kind of core functionality or some crossover, but there's also some unique things to each ecosystem. So one of the newest ones that I've been playing around with a lot is environment probes, and I'll show a little slide of this next. We also have things like world maps and trackable images. So similar to augmented images in ARCore, ARKit can actually recognize an image as well as track it as it moves around. So if you had something like playing cards or something like that, it's able to kind of lock on to that. The other thing is, and this is kind of associated a little bit with world maps, is that it can actually scan and recognize 3D objects. So if you had a unique thing like, let's say, my mouse or a certain kind of device, you can go through, scan an object. It kind of creates a point cloud using the feature points of that specific object, and then you can add kind of augmentation on top of that. So every time you recognize that object with your device, you can kind of spawn something up from there. So for an example of that is I could go and kind of scan my mouse or something like that, and then display some like particle effects coming out of it. And then anybody else who had this specific mouse could actually go use that application and have that being recognized. The other thing with the world maps is kind of similar to scanning specific objects. You can actually scan specific locations. And it's a very kind of similar feature there where it's containing all of the feature points in this kind of point cloud. And then what it's doing in the application is it's going around and kind of trying to fingerprint that on a specific location. So you could do that, like let's say on this podium or something, but as new presenters come up or as things get mixed around here, it's going to start to lose that exact kind of world map that you created. So it might be hard to kind of re-recognize that again. But if you have more static elements, you can do that. And the cool thing about these world maps is that these actually become a file on disk. So this is an asset that you could airdrop to your buddy, you could email it to someone, they could kind of dynamically add it to your application or something like that. And this is something you can either compile in with your application or kind of send over the air as you see fit. All right, so I talked about environmental probes. So this is something that I think is really cool. A big kind of key feature of augmented reality is the more you understand about the environment, the better you can augment objects in it. So a lot of these features are about kind of understanding what's happening in the environment and then applying some of that understanding to your object. So environmental probes are basically building a cube map inside of ARKit based on kind of the world and the environment that it sees. You can then take that cube map, and we just apply it dynamically to a reflection probe in Unity. And then when you spawn a shiny object, it's just like normal reflection probes in Unity. If it's close or within that reflection probe boundary, then it just takes that reflection. So one thing to note is that there's a couple different types of environmental probes. For this example here, I'm using the manual one, where when I tap on the environment, it manually creates the environmental probe at that specific location. There's also automatic, that as you kind of scan around your environment, it's going to try to put and combine reflection probes as it sees fit in kind of unique areas. So if you were doing something where an object is moving around the environment, you're probably going to want to do those automatic ones, because then the object can kind of go and get the reflections from different probes around as it moves throughout the environment. The one last thing I want to note here is that the way it builds up this cube map is that it looks at features and planes that it finds in the environment. So I've done a couple demos, and I was actually just like scanning around on the floor, and then I start scanning around in the sky. And one of the engineers at Apple actually reached out to me, and he said, hey, the idea is good, but scanning the sky doesn't do anything. And that's because I can't find any feature points just kind of looking up into the sky. So, and just from my personal experience, I found that this works a little bit better indoors, because there's a lot more things with feature points. I can kind of actually scan a ceiling if it's fairly low. It can start to build up that cube map a little bit bigger. So something to keep in mind when you are using this feature here. All right, so this is what I'm really excited about, and this is what I'm kind of going to be talking about for the rest of the presentation. This is something that's super hot off the press. We released it literally last week, and it's now kind of a part of 18.1 moving forward because it's delivered via the package manager. And AR Foundation to us is a way to bring core functionality from ARKit and ARCore into a common abstracted API for you inside of Unity. If you've been following some of our implementations for things like AR interface, that was kind of a proof of concept of if this was possible and if we can kind of have this interface on top of these SDKs. And AR Foundation is our implementation that we're going to be moving forward with as we kind of build up all these SDKs and things like that. Now, one thing I want to make note of is that right now, if you want to start taking advantage of things like environmental probes or AR maps and things like that from ARKit or something like oriented feature points, those are only available on those SDKs that I just mentioned. Right now, AR Foundation just covers the core functionality. So you can see what I've defined as the core functionality here. Things like plane detection for vertical and horizontal, light estimation, finding feature points, doing the hit testing, as well as scaling and anchors. So if you're looking for the latest and greatest, you are going to have to use those current kind of SDKs that are up to date. But with AR Foundation, the goal is to start continually adding features and continually kind of supporting what all of these SDKs support off the bat. So just kind of wanted to make sure I mentioned that AR Foundation now is about core functionality. And one thing I want to make note of is with kind of hit testing here is that with each AR SDK, they actually have kind of their own native implementation of how hit testing works. And that's because you're basically taking your device, kind of casting a ray into the world and potentially casting it against a bunch of feature points or planes and things like that. And that can be fairly expensive, so they've kind of optimized it some on the native side. All right, so now what I want to do is I want to walk you guys through exactly how to start using AR Foundation. I've done it a couple times before, and I'm going to do a little bit of live development just to show you guys kind of how easy and how lightweight the implementation is. So we'll see if this works. So first, I'm literally just going to start a brand new project here. I'm going to go into 2018. I'll call Berlin AR Foundation test, something like that. I am just going to be using the kind of built-in render pipeline and just go with 3D here so that it's super lightweight. And we're going to go ahead and open a new Unity project. So if you guys have started using 2018.1, you know that we now have the package manager included as a part of it. And if you've used 2018.2, you know that those packages actually kind of become exposed in the hierarchy. Since I'm using 2018.1, the packages are going to be a little bit hidden behind the scenes, but I will show you guys how to do this here. So first I'm going to do is go to Window Package Manager, and the way it works is that in my project, I get some kind of built-in packages that are already added, things like this UI, which is how this thing actually exists, analytics, stuff like that. And if I go into All, I can actually see a list of all available packages that are kind of out there now. So you can see I can zoom in, and you can see there's already kind of an update for the package there. These packages live on your kind of hard drive here, and they get linked in to your project depending on which ones you add. So you can see we have everything from Text Mesh Pro to Pro Builder. But for this, I'm going to get the AR Foundation. And so before I get the AR Foundation, I want to grab ARKit and ARCore. So to do that, I just go up here, hit install, and we'll hop back out so we can see. And basically, these are just linking my packages directly in my project. So we can go back here again, grab ARKit, because that's what I'm going to be building to because I'm on the Mac. And then the last one is AR Foundation. And again, AR Foundation is kind of this high-level abstracted API that's the glue between ARKit and ARCore. And one thing to note there as well is that this ARKit and ARCore implementation are added via packages. So something for ARCore is that I mentioned earlier that we have this player settings down here, if I was on Android, that says ARCore supported. And so for the package implementation of ARCore, you have to actually make sure that this remains unchecked. So this is a different implementation a little bit, and obviously these things are still a little bit in flux. We're working on kind of the UX and UI of how that's going to work in the future. But for the packages right now, we need to make sure that we're not checking that ARCore checkbox, because this is a little bit different implementation than when you get that full SDK. So I am going to go ahead and switch my project over to iOS. Kind of forgot to do that earlier. But the thing that happens here is once I get the AR foundation, once I kind of have this glue together, then I'm able to start creating a couple built-in, what we're just calling kind of XR objects. And one thing to note is that the way packages work in Unity is that there's some files associated with them. Let's see. So there's some files associated with them, but they're not actually kind of accessible or mutable, if that makes sense. And I'll show you a little bit of what I mean by that. So because I've implemented those, or I've kind of integrated those packages into my project, now when I right-click here, you'll see that there is, I guess that zoom doesn't work. Let's try this. When I right-click here, you'll see that there's now this XR tab. So this is a new tab that we've added. This is from the AR Foundation package and allows you to start adding these objects to your scene and building up how your AR is going to work. All right, here we go. So first thing I'm going to do is I'm actually going to delete these two objects. So the camera has a little bit of configuration, and we go ahead and do that for you. So I'm going to delete that, and I'm going to go right-click and hit Create AR Session Origin. And so this is actually an AR camera that now exists in the scene, and it's just created under this transform hierarchy where the session origin exists. Now, a couple things to note here is that this camera has kind of been configured to work with AR, and it's using our generic tracked pose driver, which is kind of a generic abstracted component here that can be used for any XR device. So right now, you can see that it's configured for generic XR device and color camera. We could also do things like XR controller, and then you can do like right and left. And so this is how it's super easy to kind of start targeting multi-platform, because you're just using these at kind of a generic abstracted level. But I'm just going to leave that as is for now, and just note that this camera has a couple kind of configurations on it here, and this tracked pose driver is what's actually going to be kind of moving the camera throughout the space, driven by ARKit or ARCore. All right, so now that I've created the session origin, I also want to go ahead and create an actual session. And this session, kind of similar to the scriptable objects that you've seen before with kind of ARCore, it actually just has a couple kind of checkboxes here. The one thing I want to note as well with AR Foundation is we did release it. It is still considered kind of a preview package, so expect some of the things to change. It seems like the APIs that I'm going to be using here in a moment have been kind of fairly flushed out and decided on, but potentially some of this UX or the checkboxes and stuff could deviate a little bit in the future. So for this one, we have things like attempt to update, and this is actually the ability to either try to update the device or download the latest ARCore SDK, which is actually just available on something like it's on the Google Play Store. So this is kind of a checkbox included there. We also have the ability to do light estimation. So for now, we basically have these two components here. And the next thing I want to do is I want to create my plane visualization. So to do that, I'm going to create an XR default plane. And you'll see here, by default, we again have some kind of components that we've created for you. We've added some things like a line renderer and stuff like a mesh collider and a couple scripts there. And one thing to note here is, and this is what I was talking about earlier, is this mesh render has a material applied to it called debug plane. So where does this material exist? And you'll notice that if I double click it, I'm actually able to get kind of a reference and see what's happening here, but I can't modify it in any way. And that's because this debug plane material exists in the package. And in the way packages work is that we kind of restrict the ability to modify that. So you can see this here, but I can't actually adjust any of the settings. So if I wanted to render the plane to be a little bit different, maybe I don't like this yellow-orange color, I can just easily create a new material, just like normal. We'll call this plane matte. And then from here, I can go and kind of change maybe the color. I'll leave it kind of a white gray, and maybe turn off some of these settings. So for this plane, I'm going to go ahead and just override this material with the new one I created. And then I'm actually just going to drag this plane into my project so that it creates it as a prefab. And now, in order for planes to kind of spawn and be visualized, what I want to do is go back to my session origin and add the plane AR plane manager. And so you can see from here, it actually is looking for a reference to the plane prefab. And so I'm just going to go ahead and drag that in right now. So if I were to build this out now, what we've set up is we've set up the session, which is going to kind of initialize ARKit. And we've also just configured the plane rendering to be able to kind of render and visualize planes. By default, the way AR Foundation is right now, because both ARCore and ARKit support it, is it's going to look for horizontal and vertical planes. And so that's what we have off the bat. And if I were to switch over to Android and build this out to ARCore, we have the exact same functionality. It's going to be visualized the exact same. It's just going to be running on an Android device powered by ARCore, as opposed to an iOS device powered by ARKit. Now, visualizing planes isn't that exciting, and the next thing I'm going to do isn't the most exciting thing, but it is just kind of showing you guys a little bit with the APIs for placing an object on a plane. So I'll just call it place on plane. And the one thing I want to note as well is that right now what we're doing is the kind of core functionality and all these kind of sub-menus and stuff I've created so far is available via AR Foundation, but we're creating an additional repository on top of it that is actually going to kind of have all the steps that I'm doing here pre-configured. And so that's just a public GitHub repo on the GitHub Unity-Technologies. And from there, we're going to have kind of this sample scene and stuff like that, because right now those we're not able to include those with the packages. So those are kind of just the core functionality there. So let's go ahead and open up this script here. You can see it, whoop, right here. And so what I want to do is, let's see if I can get it a little bigger for you guys, is I want to just start using the AR Foundation, basically just doing simple raycasting. And again, the nice thing here is that it's going to be working with both ARCore and ARKit. So I'm just going to be using Unity engine.xr.AR Foundation, just like that. And then that's going to give me access to these kind of APIs that we have available. So the first thing I want to do is I want to make sure I grab a reference to the session. That's how I can actually raycast against that. So I'm just going to do a AR session origin, the session origin, like that. And then in my start function, I'm just going to do a get component on that. So I'll apply this script to that session origin object. Like that. And then the other thing I want to do is when I'm raycasting, I want to kind of store a collection of all the hits I get back and then just use the first one. So for that, I'm just going to create a list of AR raycast hit. So we'll just call those hits. There we go. And the last thing I want to do is I want to have a public reference to what I'm actually going to be kind of spawning or placing in the environment. So for this, I'm just going to create a public game object, and we'll say prefab to place, something like that. Now, for the update, what I'm going to do is I'm just going to do some kind of simple Unity kind of touch input that makes sure that when I touch someplace, I'm going to raycast using the native raycast, looking for a plane, and then spawning an object at kind of the beginning phase here. So for this, we're just going to make sure that the touch count is greater than 0. And then we're going to go and just store that touch here. And just store that first touch. And then from here, we're going to make sure that the phase is basically at the beginning, like that. And then this is where we're going to be doing our kind of native raycasting here. So we're going to say if the session origin dot raycast, and we've built these APIs to be fairly similar or almost identical to normal Unity raycast. This is kind of how you'd be doing this outside of AR as well. And so from here, we're just going to take in the touch position as well as output the hits here so that we can get a reference to those. And then this is where we actually pass in what type of kind of filter or what we're looking for with this raycast. And so you can see here my IDE is kind of auto-completing there. And what we're going to do for this one is we're just going to do planes within polygon here. And so you can see if you were looking for just casting against feature points or something like that, we have that ability here as well. So there we go. And what we're going to do is, let me just make this a little bigger, just like that. And what we're going to do is we're just going to say, all right, if we've done the raycast, if we've hit something, then we're just going to store the pose of what we get back from the hit, which is just going to be hits 0 dot pose. And then we're just going to go ahead and instantiate our object at this exact pose. So just a normal instantiation for prefab to place, and then the pose dot position and the pose dot rotation here as well. So again, this is just the new APIs that we're doing, but this is fairly straightforward, pretty simple stuff of just using the session origin and then doing this AR specific raycast. So I can go ahead and save this here, and I'm going to apply this component here to the object with the session origin here, just like that. And then for the object, I'm going to go ahead and grab a little package that I have here called chair package. And one thing I want to note here with the chair, and whenever you're spawning kind of objects on planes, one thing you want to make note of is that the parent transform is kind of at the base of the object. And I'll show you guys how I've set that up here with the chair. But just consider that most of the time, if you want to place an object on the actual floor, you're going to be finding these horizontal surfaces. And then when you spawn the object, you want that transform to be at the root and then kind of offset the object based on that. And we'll see here this in a moment. And then the goal is to build this out to my iPad here, and I can show you guys how it's kind of visualized. And then I've pre-built it, you guys just have to believe me, on my Android phone here as well. And the other thing to note, and you'll see this, I'm going to kind of intentionally make a couple errors here, but we do have a lot of things set up to kind of catch you along the way and make sure your settings are all configured correctly. So for my chair here, as I mentioned, you'll notice that, just turn my gizmos down, you'll notice that the root here is at the very bottom. And again, that's because when I spawn it on the plane, I want it to be sitting flat kind of in the environment. So by default, this chair's transform is kind of near the center. So if I were to just take that as is, how I got the asset, it's going to be kind of down underground, which isn't going to really look correct. So we can just put an empty transform here at the root, and this is that object that we're going to spawn. So to quickly do this, we can go and just drag that over here. Now I'm going to save the scene, and we can go ahead and hit build. So if I hit build now, it's going to, let's just do like this. It's going to complain right away that I haven't properly set up my camera usage settings. And so we can go back in here, and I'm also going to have to do the bundle identifier here. And for camera usage, there's this little description right here. I'm going to say use AR. And then for this, we'll just do Dan test Berlin AR found. So now I can go ahead and hit build and run. And what it's going to do is, this is just kind of normal iOS development. It's going to go ahead and package everything up for Xcode and then build it and push it out to my device here. So the cool thing, again, is that to me, this is super lightweight. It's very kind of accessible for this core functionality. You can easily build it for iOS, switch it over to Android, And the really nice thing is that because with the way we've set up the packages and because of some of the dependencies and stuff, you can keep that and maintain the core, the same code base across both platforms. So if you're developing this on your Mac and then you have a desktop PC or whatever, you can just easily kind of save that same code base and then start building for different platforms as well. So you can see as this builds out right now, I will go ahead and actually switch to my Android device, which has a build of it already. So let's go ahead and try that. Let's see here. Let me try to replug this in sometimes. Let's see. There we go. All right. So what I'm going to do is I'm just going to look around. Here is the plane being visualized. And when I touch it, now we have a chair. So again, just the same functionality, basically the same code base. I ran through the demo previous times. And the way it works is that we can actually just spawn chairs kind of all around. And I've said that it's able to do both vertical and horizontal planes. So if I wanted, I could start just putting chairs on the side as well. Now we're just kind of getting a little maybe MC Escher or something like that, where we can just spawn objects. And the reason that it's locking and orienting to that is because I'm using that pose that I cached from the hits. So you can see that that pose has the transform and the rotation of kind of how I'm hitting against those plane. And now, what I want to do is switch back over here, fix my profile here, and go ahead and build it out. Let's take a moment here. And I've also, there we go. So we're going to start to build it out. And just to kind of show you guys that this is more of a real build, I have it kind of configured through here. So this is just my iPad. And you'll see it kind of automatically launch and stuff like that as it starts to build. And again, you saw that basically the place on plane script that I have, that's kind of shipped in that external repo. And us at Unity as well as myself, I'm going to actually be contributing to that a lot, building up a lot of these sample applications and kind of adding functionality to that so that you guys can get started right away, check out the APIs, see how you can kind of use them and things like that. So this is almost done building here. All right, and now if I switch back, you'll see it added right there, and it should auto-launch here in a moment. There we go. And now we'll see if we can emulate exactly what we just saw on the Android phone, instead using ARKit. You can see right there, I need to accept kind of permissions. There we go, and here is our chairs right there. And same sort of thing right there. Same code base, using AR Foundation, easily kind of building it up in a very lightweight manner using the packages and things like that. So that's pretty much it for my presentation. But thanks a lot for coming, and I think we have a little bit of time for questions, and I'll kind of be around after there. So thanks.